Okay, class, as we start 10.3, we are looking towards learning target 10C. It says, I can simplify expressions using the division properties of exponents. So I've incorporated the activity from the book onto the first page of notes, just because I think it would be pretty helpful. So I'm going to get you started just on the first one here, and then you can kind of fill in the rest of the table. So, again, our goal is kind of similar to 10.2, where we eventually don't want to use this middle part, and we just want to look for like a shortcut from the beginning to the end, right? So, but just to get there, just to recognize the shortcut, let's look in the middle here. So a quotient, remember, is division. So what we're looking at is 2 to the 4th power divided by 2 to the 2nd power. Now, I'm just going to kind of repeated multiplication form just means I'm going to rewrite it. So 2 to the 4th means 2 times itself 4 times. So I have that right there. And then in the denominator, I have 2 squared. So 2 times 2, okay? Now, if you remember fractions, anytime you have like 2 over 2, that cancels, right? That becomes 1. So, for example, like this pair of 2's right here, like I can cancel that because they pair up, right? There's another one that I can pair up here. Now, I've canceled as much as I could. What I have left over is in the numerator 2 times 2. So I'm going to rewrite that in this last column. So 2 times 2 is 2 squared. Okay? So what I got from the beginning here was 2 to the 4th divided by 2 squared. Then I ended up with 2 squared, which was simplified. All right? So what I want you to do is fill out the rest of the table, okay, on your own. Do the middle column and then the end. And then there's some questions at the bottom of this first page that I'd like for you to answer if you can get there, okay? Pause the video. When you're ready, you can press play and then you'll see my table filled. So, I'm going to be honest, as I was filling in the table, you could see clearly that I got kind of tired of writing all the repetition. But look at the right-hand column at least, and make sure all of your powers match with mine. And if so, I stopped right in the middle of the table, and somehow I was able to still figure these last 3 out without having to do repeated multiplication. So what kind of pattern do we recognize? And that's kind of on the next page here. But before I go to the next screen, what you'll notice is as long as you have the same base, and one's in the numerator, one's in the denominator, you just need to subtract the exponents. Right? So if you look 3 to the 12th divided by 3 to the 4th, I subtracted 12 minus 4, and I have 3 to the 8th. Because if you think about, that's how much I have left over after I cancel things out. So I'm going to kind of slide down to the next part here. To this part where it says describe the pattern in the table. And so what I recognize is that when I have the same base that's being divided, then I subtract the exponents. So that's kind of the pattern that we see in the table. Please make sure you have that rule copied down. So then, like a general rule, if you have like, I know this is all variables and no numbers, but if you have like a to the nth power divided by a to the nth power, the a base stays the same, so as long as there's the same base, and then you just subtract the exponent, numerator minus the denominator, m minus the n. If you need to pause that and kind of rewatch that again, please go ahead and do so, otherwise I'm going to move on to the next page. So that's essentially what we're looking at, right? This is, I'm just kind of rewriting the rule here. This is from the book. of what happened. So let's do some examples. We're not going to actually answer them, but we're just going to simplify them. Okay, so example 1a, 2 to the 6th powered over 2 to the 4th. They're the same base, so I'm just going to keep that base and then subtract the exponents to make it simple, 2 squared. Example B, same thing, same base, so I'm going to keep that same base. Make sure the negative 7 is all in parentheses. 9 minus 3, numerator minus denominator, is 6. And it doesn't really change if it's a variable, so h to the 7th divided by h squared, as long as my h is still the same, that's going to be my base, and then I subtract 7 minus 2. So try these on your own problems, numbers 1, 2, and 3. Pause the video. When you press play, the answer key will kind of show up. Here are the simplified versions of each of these exponents. So 9 to the 3rd power, number 2. You know, number 2, I didn't write 4.2 to the 1st power. When you don't write anything, it's just assume that there's like an invisible 1 exponent in there. Okay, so if you wrote it, that's fine. All right, and then number 3 was the one that involved the variable. So that's kind of the new thing for our learning target today. In the next slide, let's just get to the next page. So now in these examples, you'll see that there's multiplication and division. So just as like a quick side note about multiplication, I'm just going to write a little reminder here. So my two situations, when I multiply the same bases, then I'm going to add the exponents. That's what we did in 10.2. When I'm dividing the same bases, which is what we're learning right now, then I'm going to subtract the exponents. Okay, so their example 2 is just a combination of both. So in my numerator, I see 3 to the 4th times 3 squared, all of that divided by 3 to the 3rd. Now, I'm going to go one at a time instead of trying to do everything all at once. In my numerator, let's deal with that multiplication part. 3 to the 4th times 3 squared, that gives me 3 to the 6th power because I add the exponents. I'm going to keep that denominator 3 cubed. So now I've simplified it already. And then now with the new learning target, 3 to the 6th over 3 cubed, I subtract numerator minus denominator exponent. And so it simplifies to 3 to the power of 3. Now, for example, B, I could multiply first or divide first. It honestly doesn't matter which order. But let's divide first, just for the sake of dividing. Okay. So this one right here, a to the 10th divided by a to the 6th. So since they're being divided, that means I'm going to subtract the exponents. So a to the 4th. And then I'm going to bring that multiplication part down. And then I'm going to simplify this one as well. A to the 7th divided by a to the 4th. Again, I'm using that property of division, so that means I'm subtracting the exponent. So a to the 4th times a to the 3rd. Now I can simplify going left and right even more. A to the 4th times a to the 3rd means I can add the exponents to simplify. So that complicated problem from the beginning simplifies to a to the 7th. If you need to rewatch that after you've copied that down, you know, rewind the video to this example 2, just because I know it can be a little bit complicated as we're now discussing two different learning targets. If you feel like you can do the on your own problems on your own, then pause the video and just wait for an answer key. Here are the simplified expressions for the on your own problems. Number 2, I do want to make a note here. Again, so if there's no exponent written, that means there's an invisible 1, right? So d to the 5th divided by d to the 1st, simplified to d to the 4th. And then even here, let me highlight so that you can see, even here, It's d to the fourth times d, which is really d to the first power. If you, again, at any point, if you need to rewind the video, please go ahead and do so. We're going to go to our last example, which is a word problem. So, it says the projected population of Tennessee in the year 2030 is about 5 times 5.9 to the 8th power. The image on the right shows the approximate area of the state of Tennessee. Predict the average number of people per square mile in 2030. You know what? There might be a typo here. I don't think this is supposed to be here. I think it's just 5.9 to the 8th in the problem. Sorry about that. So per square mile, predict the average number of people. Average, what we do here is like we take the total amount, divide that by the area, right? So that's kind of the idea right there. Total population, divide that by the area of the land. So if we were to fill that in, total population of people, we have about 5.9 to the 8th power. Divide that by the land area, which it says 5.9 to the 6th power. And so we recognize that, hey, they have the same base, 5.9, so I'm going to keep that base, 5.9, and I'm going to subtract the exponents to get 5.9 squared. So the average number of people per square mile in 2030 is going to be 5.9 squared people. Just writing a sentence here, since a story problem, that means I'm writing a story at the very end. There's just one last on your own part which relates heavily to this, just kind of keeping the same information in mind. Here's the on your own problem. The projected population of Alabama in 2030 is about 2.25 times 2 to the 21st power. The land area of Alabama is about 2 to the 17th square kilometers. Predict the average number of people per square kilometer in 2030. You know what? I am realizing that there was not a mistake in the beginning, but since I can't rewind and edit, this actually is the projected population. So you can kind of keep that setup in mind. So meaning like the population divided by the land area again. So what that means is you have 2.25 times 2 to the 21st power, and then the land area is 2 to the 17th power. So this is actually something that you can do. Take a minute, try to solve this, try to simplify it. Yeah, pause the video, try to simplify it. So actually, my mistake from the beginning, or from before, was that I crossed out a number. Now, if you look across in the numerator, 2.25 times 2 to the 21st power, hey, this is exponent 1, so that I can add these exponents. But you can't do that because this base and this base are not the same. So what that means is that I can't deal with that, but I can look at up and down, okay, my numerator and denominator. I can deal with that. And so since they have the same base, that means then, my numerator, I'm just going to kind of keep that 2.25 there, since I'm not really doing anything with it. But then 2 to the 21st over 2 to the 17th, I can keep that same base 2 and then subtract the exponent there, 2.25 times 2 to the 4th power. It's a little bit awkward, but awkward number, but that is the final simplified version. So I'm going to write a story here. There will be about 2.25 times 2 to the 4th people per square mile. If you need to rewatch any part of the video just to kind of make sure you got the target, rewind to any part of it. Otherwise, you can go ahead and start practicing on your own.